Right, I'm going to look at sequences for my Year 8 group. It's on to do with Mastery of Mathematics. It's to do with one of the BAM tests, which is short for Building a Mathematician. So it's Stage 8, Unit 8, to do with sequences. Okay. Now, sequences are numbers or patterns which follow a particular rule. I'm going to look at two types of rule here. The first type is the term-to-term rule. The term-to-term rules. So let's take, for example, a sequence. Let's go, I don't know, let's say 5, 9, 13, 17. Now you might be asked to describe that sequence. Okay, you can see that term to term, that's the first term, that's the second term, that's the third term. So you can see you're adding on 4 each time. So if you were to find the missing two numbers here, add 4 on to 17, that will give you 21. Add 4 on to 21, that will give you 25. And that's the term to term rule there. 5, 9, 13, 17, 21, 25. Term to term, you're adding on 4 each time. You could have different term to term rules. For example, I could have 20, 17, 14, and so on. And this time, obviously, you've got to also think here as well with your rules. If it's to do with add or multiply, if there's just an add rule on its own or a multiply rule on its own, we know the numbers are going up. If it's to do with divide on its own or subtract, then obviously the terms are going to drop. In this case, you can see here, you're taking off 3, so that will be the term to term rule. Take off 3 there, 4, 11, and 8, and so on. Okay? So, if I just take those off here and then write some more sequences which follow term to term rules. Just make that a little bit better. Okay, well, let's look at this one here. 2, 4, 8, okay, and so on. Okay, so here you can see on this particular sequence, let's just change the colours a bit. Now they're going up, so you'd think it was an add rule, where you can think of add 2, add 4, okay? But if I give you the next one here, okay, does that fit that? So you've got add 2 there, add 4, add 8. You can see that the numbers are doubling up there. But another way of looking at it is, for this one, you are timesing that by 2, times then that one by 2. So term to term, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and so on, 64, etc. So the term to term rule there would be times by 2. So if you're asked to fill in the numbers, I've done that. If you're asked to describe the rule, you'd write term to term rule is equal to multiply by 2 or times by 2. Another one we could look at is, let's look at 200, 100, and 50. Okay, this time you can see there they're going down, so if it's a rule on its own term to term, you can either subtract, or you're taking off 100 there, but you're taking off 50 there, so you can look at it that way. The other way around it is to look at that, it's being divided by 2, and does that work? Okay, well if I give you more terms there and said that was 25, then it would fit definitely. Each term to term, you divide it by 2, in other words, halving it. So half of 25, if you had a calculator, they could do it out, it would give you 12.5, and half of that again, if you were to go further, ideally you need a calculator here to help you a bit, that's 6.25, etc. So they're all the sorts of term to term rules there. Okay? Now, carry on with the term to term rules there. Let's just rip that bit off there. Term to term rules. So let's look at a special types of term to term rules, yeah? And I'll leave the very special one to the very end of this this talk. Let's look at the sequence which goes 2, then it goes 3, then it goes 5, then it goes from that 8, and from that you have got 12. Now that's sort of not one of your normal sequences, yeah? you're not doubling each, you're not adding on the same number each time, so add 1, add 2. But what you do notice is, this increases by +1, that increases by +2, +3, +4. So if you were to fill that one in there, and say that you wanted the next 2 numbers, you can see therefore you would add 5 onto that. Well, 12 and 5 would give you 17, right, okay, which is there, and then 17, next one, is add 6, which is going to give you 23. Now, how do you describe that? Well, the term-to-term rule, if you were to ask that, would be, well, it's all the multiples you increase in, so you add in the multiples of 1. Okay, so multiples of 1 are being adding the multiples of 1 each time, or increasing by the multiples of 1 each time. Okay, and you can see you get that from there. Right. What you could also be given is the actual term-to-term rule. It could be more complex. For example, okay, to generate a sequence, you've got to know the starting number, and you need to know the rule. And I'm talking about term-to-term rule. So let's say here, I tell you that the term-to-term rule is multiply by 2, add on 1. And I'll tell you that the first number of the sequence, let's call it, I don't know, 3. So you start with 3, and we know what we do term to term. We multiply by double it, then add 1. So, which you calculate if you've given that in the test. 3 times 2 is 6, add the 1 would make 7. Next one, okay, again, times by 2, add on 1. 7 times 2, the next 7 times 2 is 14, add 1 is 15, and so on. So you might be asked to fill in, there's so many there. Times that one by 2 is 30, add 1, 31. Double that, times it by 2, 62, add 1, 63, and so on. So it could be, so to generate a sequence, you know to need the first number, and you would need to know what the term-to-term rule is. And that's really, that's one way of representing a sequence from term to term. There's a more, a better way of being able to generate the terms in a sequence, and this is something called the what's called the position to term formula. So position to term rule, not term to term, but position to term rule, also called the nth term. Okay. Now, how does this work? Well, let's, for example, take a particular sequence. Let's say we've got, should be up there, 2, 1, so 3, 5, 7, 9, and so on. Now, let's compare the rule I've just got. The term-to-term rule, which is what we've just done, I've just talked about, would be what you do from term to term. You can see there you add on 2. If I now talk about the position to term rule, okay, you'll have to come up with this rule. It's actually, I'm going to give you the formula here and then talk about how to generate that formula. It's actually 2n add 1. Now what does that mean? Okay, well, if you write down the terms of that sequence, 3, 5, 7, 9, and so on, what it does, it doesn't, obviously the term to term, which is add 2, as I've demonstrated there, does what it does, term to term, next term, do that, add 2 on each time. But what the position to term rule does, or also called the nth term, it links up the position. So that's number 1, so number 1, first term of the sequence is 3, the second term of that sequence is 5, the third term is 7, and the fourth term is 9, and then we can do it for any number terms, n for any position, 1, 2, 3, 4, whatever. And what you're doing basically here, or what you are doing, is you get in the position and you times it by 2, then adding on 1, and you keep doing that. Second position, times 2, add 1, times 2, add 1, and then do it for any position, times 2, add 1, which will give you 2n plus 1 as the general formula. So, for example, if you knew that was your nth term, talk about this one, then you put your first position in. So position 1 is 1, so you do 2 times 1. 2 times 1 is 2, add 1 is 3. Put number 2 in now to get the second term. The second term is, well, remember that n is the number of terms. Okay, so n is the position. So I want the second term. You put 2 in. 2 times 2. 2 times 2 is 4. Add 1. 2 times 2 add 1 gives you 5. Put 3 in. What 3 will do is that n is the position. Okay, make that clear at the top here. N equals the position. When you do use the position to term rule or nth term. So it equals 1, 2, 3. So if you want the first term, you put 1 in. If you want the second term, you put 2 in. You put 3 for the third term. If you want the 100th term, you just put 100 into the formula. It takes you there straight away, much faster than the term to term rule. And you can go on here, put 3 in. 2 times 3. 2 times 3 is 6. Add 1, 7. And it does all that for you. So that's the difference between it then. So term to term does what it does. Position to term links the position to the actual term. It's much quicker, it takes you there much faster. Okay, for example, on that, if I wanted the 100th term, that would be a lot of counting. That's the first, second, third, fourth term. So 100th term, I'd have to write 100 of those out, too long. So what I do is I want the 100th term, I replace n by what term I want it at. I want it at position 100. So you put 100 into that. 2 times 100 is 200 plus 1, and it's 201. It takes you there very fast. So let's now move on to this rule here. Leave that on the board. So called the position to term rule. Let me just move that. So for example, we'll come to generating this formula in a minute. Let's say I've got the formula, I don't know, 3n and take away 1. That's the formula. Okay. What that does, it relates the position, and when you get the position, you times it by 3, take away 1, it will work out the terms at those different positions. So if I wanted the first 4 terms or first 5 terms of that, I'll put 1 in. And what I do is I do 3 times, replace that by 1. Okay, all I'm doing is replacing n by 1 because I want the term at position 1. Take away 1. Obviously you do the times first before the subtract. Remember BIDMAS. You can see in BIDMAS or BODMAS, we call it BIDMAS now. We do the n multiply before the s to subtract. 3 times 1 is 3. Take away 1, which means the first term of that sequence is 2. So here we go. We then put n equals 2 in. Now put 2 into the formula, so it goes 3 times, replace the n by 2, so I'll use a red. You can see that, there's the 2 going in, and don't forget to take away 1, because that's what the rule says. BIDMAS, do the times before the add. 3 times 2 is 6, take away 1, leaves you 5. So the second term of that sequence is that. Okay? Put n equals 3 in. You do 3 times, now you place n as 3 in, because you want the term at position 3. So 3 times 3. Don't forget to take away 1, circle that. 3 3s are 9, take away 1 leaves you at 8. And you keep doing that and so on. Okay? Spotting a pattern now. Okay? It's going up in 3s there, so 11 and 14, because we know there's a link to the formula which I'm coming to in a minute. And that's how you do that from there. I could give you another formula on the board there, let's just remove that. So let's just give you a new nth term, one more. Same thing again. Okay, that's, I don't know, 7n plus 3. So again, that will work out position to term rule called the nth term. So you put the position in that particular position, it works out the term of that position. So you put n equals 1 in, that will work out the term of position 1. So you go 7 times n, replace it by 1, because you want the first term of position 1, add on 3. Okay, there. Do the times first, so 7 times 1 is 7, add 3 is 10, that's the first term. Put n equals 2 into the formula. Okay, here we go again. So you go 7 times, now I want the term at position 2, so replace n by 2. Okay, then we get to add 3 at the end. BIDMAS times before you add, 7 2s are 14, add the 3 is going to give you 17, and n equals 3. Okay, 7 times n, which is 3, replace n by 3. Don't forget to add 3 at the end. Okay, here, do that bit first. 7 3s are 21. Add on 3 gives you 24. And we're starting to generate the sequence, which is going 10, 17, 24. And notice it's going up in 7s, so add 7 on that, 31. Add 7 on that, 38, etc. And that's that there. Now, how do you generate that formula? Well, I'm almost been giving it away there, because if you look at it, because it's going up in 7s, the formula goes 7n. So this number here in front of it is what the sequence goes up or down in. Let's go and talk about that in more detail. So, let's put that on the board there. N is the position, equals position. Got that there. So, let's look at finding the nth term. Okay, finding the nth term, or the position to term rule, finding the nth term. How do you do it? Well, the formula is linked to this. It's something to do with a lots of n plus b. We need to know what the a and the b are. Okay, so if I put one on the board here, okay, let's say we've got, I don't know, 5, 8, 11, 14, okay, how do we get it from that? Okay, well, we can see it's going up in 3s. Okay, term to term is going up in 3s, and that is where the bit here comes from, right? How many multiples of n, because it's behaving like the 3 times table. Not actually starting at the 3 times table, which is 3, 6, 9. It's starting and moved on a bit from the 3 times table, but it's still going up in 3s. So that means we know the a bit here is 3, this number here. So we know it's got something to do with 3n. Okay? Now, to get the other number at the end here, there's a little trick. What you do is you look at the number before the first term, which isn't part of the sequence, so I'll put it in blue here out of the way. But if you're going up in 3s here, if you go back 3 from here, that must be 2. So that is the key number you put at the end. Check that, 2 add 3. Now, that is not part of the sequence, that's still the first term, that's still the second term, remember that, and that's still the third term. That's just a little trick to be able to get that end number. So the 2, the b is the 2 bits here. Okay? Okay? Basically, in a nutshell, it's like the 3 times table. Okay? So if you think about your 3 times table, 1 3 is 3, 2 3s is 6, 3 3s are 9, 4 3s is 12. But it's not actually directly all multiples of 3. What's happened is every one of those numbers has moved 2 onwards. Add that onto 2 gives you 5. Add that onto 2 gives you that. So it's like moving, it's like translating or moving the times table 2 ahead. Yeah? And that little number at the end comes from writing the number before the first term. So your nth term there of that formula will be equal to a lots of n, because it's going up in 3s, it's going to be 3n. And then to get the number at the end here, you go back from the first term, or because it's going up in 3s, go back 3 there, that's 2, because that was 2 add 3. That's not part of the sequence, and that you put that on the end. And that's your formula there, yeah? Now, just to put that in words there, a equals the value it goes up or down in. In this case, it was going up in 3, so a was 3. And b equals the value before, underline that, the first term. So the value before the first term here, because they're going up in 3s, go back 3 there, that must be 2, because 2 add 3 gives you 5. So the term, it's not part of the sequence, that's the trick to be able to get the number there. Now, that's your formula, check it out. So for example, if I say put a number into that, my first term is 5, my second term is 8, my third term is 11, fourth term is 14. So if I was to put, for example, what shall I write over here, let's go in red here, n equals 4 into my formula, okay, I would put it into the formula and test it works out. The fourth term should be 14, so let's check it out. So we do 3 times what's n, well I'm putting 4 in, so I'll put that in red, 3 times 4, then don't forget to add 2 at the end here, because that's what the formula says, 3n add 2. Bid mass times before you add, 3 4s is 12, add 2, bingo. Does it give you 14? Yes it does. The fourth term, 4 in, fourth term, first, second, third, fourth term is here, 14 works out. And that's how to get those formulas very quickly, and that's the sort of probably the hardest bit, but the little trick there does work. If you were to draw a graph, you get a straight line. And there's another word that we'll use here, you can get that, I've said that, is the word linear sequence, yeah? And what we're doing there, we're working out, so the nth term of a linear sequence. That's what I've just been doing, and that's the bit which will be on your test. Okay, that's what I've been looking at there, the other ways. Well, a linear sequence goes up or down by equal amounts. Okay, that's what we've been doing. So just to demonstrate this quickly here before I go into the special sequence at the end. Let's say I'll make one up here. Let's say we've got, I don't know, 1, 7, 13, 1, 7, 19, 25, and so on, because it'll go on to infinity, never stop. How do you get the formula for the nth term? Well, we know the term to term rule is add 6 here, which helps us to be able to get the nth term. Well, I've already said to you that the nth term, or position to term formula, is going to be a lots of n plus b at the end. Now the a comes, as I said in my notice before there, is what it goes up or down in. We can see it's going up in 6s, term to term. So therefore, we know here, this bit here, a will be 6. Now b is the value before the first term. Well, it's going up in 6s here. What's the number? We'll go back 6 there. 1 take away 6, use your calculator. You will get -5. Check it. -5 add 6 is that. That's the number b. It's not part of the sequence. That's still the first term. That's the second term, third term, fourth term, fifth term. So b is -1. So you put that on the end there, and you get the formula there, the nth term, which you'll write. They ask you for the formula, nth term. It's going to be 6n, take away 1. Check it. We'll put a number in. I'm going to put 4 in again. The fourth term, first, second, third, fourth term should be 19. So if I replace in that formula n with 4, the fourth term, that's what it'll do. That formula, put position 4 in, you go 6 times, I'll put in colour again, 4, and then don't forget the formula says take away 1 at the end there. Bid mass times before you subtract, 24 take away 1 gives you 23 there. What's gone wrong there? Sorry, 26 times, it's going up in 6s there. Got that right, so it's going up in 6s. Oh, mistake, always check your work. Just get rid of that, stop there, rub that off. I made a mistake there. I put the wrong number, I put take away 1 at the end there. Yeah? It should be take away 5, so start again there. It's my mistake, rather you see me make a mistake. Okay, for you to check your work, because that didn't check out anyway. It wasn't giving me the fourth term, it wasn't making sense there. So, just go again. Nth term equals an plus b. Don't check myself out here. A is the value it goes up or down in when it's going up in 6s, so a is 6. B is the value before the first term, so it's definitely -5. So my formula will be an 6n -5. I put -1 there, didn't I? Now, that's why you check your work. So if I now put n equals 4 into that, that means I'm going to work out the fourth term. So here we go, so we can get better. 6 times 4, put that in red. Okay, 6 times 4, that's what it's take away 5 at the end, not take away 1 or wherever that from. Bid mass times before you subtract. 6 times 4 is 24, take away 5 should give you 19. First, second, third, fourth term is 19. Check out, got the formula right, and you can do them all the time there, yeah? That's how you get those. One more quickly on that. Let's do another one. Let's have, let's have 10, 13, 16, 19. Okay, what do you see here? Well, they're definitely going up in 3, so term to term rule would be add 3. It's a linear sequence because it's going up or down equal amounts, it's going up by equal amounts. Remember your nth term is going to be an plus b. A is the value it goes up or down in when it's going up in 3, so A would be 3. B is the value before the first term. Well, this is the first term, that's your first term, that's your second term, that's your third term, and that's your fourth term. So the value before it, when you go back 3 from there, you can see here it's 7 there. It's not part of the sequence, but what it cleverly does, it adjusts the 3 times table on the end there to put it in line with that sequence there. So therefore, B would be 7, and therefore your formula for your nth term, well, this is the answer you'd write down, is AN, but it's 3n, multiples of 3, it is. But the 7 moves the 3 times table 7 on, plus 7 at the end, and there is what you get in the answer. Check it, because I made a mistake earlier. So I'll go 4 again, you can go 3, we'll work the third term out, which is obviously 16, I'll go 4. The fourth term is going to be equal to 3 times n, well n is equal to 4, because I'm going for the 4, I'm picking 4, I could have picked any. 3 times 4, add on 7, times before you add bid mass, 3 fours is 12, 12 plus 7 gives you 19, is the fourth term 19, 1, 2, 3, yeah 19 on that one. And what this formula is, very clever about this formula, is, yeah, well that's the formula, if I was asked you to work out the 100th term, that's a lot of counting, so if you did the term to term rule, you keep adding 3, but they're all there, that's 4, 5, 6. I want to get straight to the 100th, which is way down here. What this formula does, the term to term rule, and the term just relates the position straight in there. So if I wanted the 100th term, all I do is replace n by 100 in the formula. Yeah, if I wanted the 50th term, I replace n by 50. I'm going for the 100th term here. So the 100th term is equal to 3 times n, well I'm going for the 100th term, so it takes me there quicker, 100. Don't forget to add on 7 at the end. Bid mass times before you add, so it gives you 300 plus 7, look how quickly I've got there, 307. And that's there, from there. Okay, that includes all the sequences work which I've done on the test. There's just one other thing I'll mention. Okay, 2 extension questions, because on the test there's a general fluency area, and then there's the problem reasoning skills, and that's a little bit harder. So see, obviously if going through this gives somebody a chance to get maximum marks on this test. Okay, so let's now look at, well, let's go back to the 2 challenging bits. Let's say I've got my nth term is equal to, I don't know, 4n take away 1. Okay, and let's say I want to know, right, I'm going to make this a bit harder now. Let's say I want to know what is, let's say I've got a term, my term is 79. That's one of the members of the sequence, yeah? Okay, remember what you do, you put 1 in, 4 times 1 is 4, take away 1 is 3, that's your first term. Put 2 in, 4 times 2 is 8, take away 1 is 7, that's the second term. Third term, 4 times 3 is 12, take away 1 is going to give you 11 from that, that's the third term. Now I'm basically, this is the extension question, down that line there's going to be a term which is 79. What position in the sequence is it here? What position n, what value of n does that add there for the position? How do you get it? Well, you could keep counting on like that and get there eventually. That's a lot of counting, especially if that number's big. So I've got a better way of doing it. The formula works out the terms. So I know the formula's giving me 79 for a certain position. So I'm having to work backwards there. So if I just swap round, because I work left to right, 4n minus 1 equals 79. We've done solving equations. If you remember what we did here, we leave what's attached to the solving letter to the end. We tend to leave that to the end. So how do you get rid of minus 1? You plus 1 on both sides. Okay? That gives you, this is extension, remember, so just for those who feel they can get that. 4n, they cancel out, opposite cancel, 79 and 1 is 80. That's times by 4, so how do you get rid of times by 4? You divide by 4, put that in blue, you both sides. Divide by 4 cancels out, leaves you 1 and 1 n is n, so that gives you what I want, position. 80 divided by 4 is 20, it's the 20th value of that sequence. So therefore the position is equal to the 20th, it's the 20th value in that sequence. Yeah, is number 79. Check it, put n as 20 in, 4 times 20 is 80, take away 1, 79. So it's like working backwards off the formula, a bit harder there on that one, I've thrown that one in. And then finally, That's just a bit of one of the difficult ones there. And finally, I'll look at a rather special type of sequence, which I probably have set up on the homework, maybe on a maths watch online. And it's this sequence, something called the Fibonacci sequence, yeah? Fibonacci sequence. And what it is, it's well, you can make your own Fibonacci sequences up, okay? And what it is this. It's actually relates lots of things to real life in nature and things, yeah? Lots of these numbers crop up, whether it's the petals on a flower going round, or the cones that it spirals around, actually follows these numbers and many, many more. And what actually happens is this system. Now, obviously I'll put another one there. Basically, I could actually fill these in. And what happens is, to get the next term, right, and you have to go from the third position, yeah? So to get the next term, so from position 3 onwards, the rule starts to work. So obviously that's number 1 in the sequence, that's number 2 in the sequence, that's number 3 in the sequence, that's number 4, number 5. So you're going for position 3. To get the next term, yeah, you add the previous 2 terms together. So to get the 2 there, yeah, that 2, you add the previous 2 together. So 1 and 1 makes that. Now if you move along the 1 now, to get the next term, 3, yeah, you add the previous 2 terms together. So 1 add 2 gives you 3. Moving on, to get that term, which is the 4th Fibonacci number, add the 2 previous numbers together, 2 plus 3, and so on there. So, you now think about this logically there. To get that number there, which is missing, you add the previous 2 together, 3 and 5, so obviously you get 8. To get that number, you add the previous 2 together there, which is 30, and so on. Okay? And that is actually the Fibonacci sequence which you came up with. You can make your own Fibonacci sequences up. Okay? So I'll just show you that quickly. So that is called the Fibonacci. Let's make a new Fibonacci up. So I can make any numbers up here. I might have 3 and 4, and now we go. To make that term, you add the previous 2 together, 3 and 4 is 7. Next one, to get the next term, you have the previous 2 together, so 4 and 7 makes 11, and it moves on like that. To get that term, you have the previous 2 together, so 7 and 11 make 18. I'm making my own up here. To get that one, you have the previous 2 together, 11 and 18 gives you 29, and so on. It goes on. That's the type. So the Fibonacci sequence, starting from the 3rd term onwards, is you add the previous 2 together. So 7 is 4 and 3, 11, previous 2, 4 and 7, 18, add the previous 2 together to make that, and so on from there. I think that covers, the majority of sequences. There are more to sequences than that, but for us at stage 8, unit 8, that covers what we will be doing on the test, and all the areas of sequences, term-to-term rules, nth term, working them out, using the formulas, etc., and explain them with the extra special one put in there, which is the Fibonacci sequence. Okay. Good luck for your revision for the test, and let's smash that test and get full marks, because I'm sure you can with the revision I've given you and this video as well. Thank you very much. Oh, don't tell me it's gone.